I'm just trying to clear off the calculator. So if we decide we need to use it, I don't have any surprises. Okay. So this is our cost function. Going to work on part A. C of x equals 100 plus 15 minus x squared. As long as x is between 0 and 7, we want the average change per case. So that's a rate of change, average rate of change. In the total cost, if the number of cases manufacturers goes from 1 to 5. So we're going to end up at 5 and start at 1. And the cost for 5 cases will be the first cost. And the cost for 1 case will be the other cost. So if we have 5 cases, that's 100 plus 15 times 5. Oops, not plus, minus 5 squared. So that's 150. And then if it's 1, the cost of 1 case is $114. And 5 minus 1 is, of course, 4. So 150 minus 114 and then divided by 4 is 36 over 4, which is 9. And that's, since C of x is in dollars, that's $9 per case. Okay? Then we're supposed to find the additional cost when production goes from 1 to 2 cases. Okay, we already know the cost for 1 case. That's $114. So we need the cost for 2 cases. The cost for 2 cases simply changes the 1 to a 2. So for 2 cases, it costs $126. So the second case cost us $12. Okay? Because that's really all it asks for. And then we'll move on to question C. What is the instantaneous rate of change with respect to the number of cases produced if you produce just 1 case? For the instantaneous rate of change, we're going back to this. Okay? So this is what we've got. There's the cost function, and there's the function for instantaneous rate of change. Now I'm going to do this step by step. I'm not going to try to do it all in one big long fell swoop. The first thing I'm going to do is I'm going to try to find this part of the function. And in this particular case, since the number of cases we're looking at is 1, the value for A is going to be 1. Okay? So f of A plus H is f of 1 plus H, which is equal to 100 plus 15 times 1 plus H minus 1 plus H squared. Any questions on that part so far? That's why I prefer not to do it on the PowerPoint. You know why we're doing what we're doing? I'm just trying to break it down and make the algebra part easy, the arithmetic part easy. So first thing we want to do is we want to simplify that because, I mean, let's face it, that's pretty ugly. So that's going to turn into 100 plus 15 times 1 is 15 plus 15 times H is 15H minus 1 plus H squared is 1 plus 2H plus H squared. Remember, that's 1 plus H times 1 plus H. Oh, and my squared goes inside, not outside, sorry. So now we need to change all these signs . And see what we can get rid of. If there's anything will drop out. Let's see, 100 plus 15 is 115. Minus 1 is 114. There's nothing to do with the H squared out here, so I'm going to leave it alone. But 15H minus 2H is 13H. Okay? So this is f of A plus H. I'm not going to do anything else with it yet. I'm just going to say that's what it is. Then I'm going to move to what is f of A. F of A is just 1. And f of 1 is 100 plus 15 times 1 is 15 minus 1 squared is 1. 100 plus 15 minus 1 is 114. So there's f of 1, 114. And then what this tells me to do with all of that is to take 114 plus 13H minus H squared and subtract f of 1, which is 114. Because what I'm ultimately going to do with this is I'm going to divide it by H and find the limit as H approaches 0. That's how I'm going from here to here. I did this part first so that we didn't lose track of anything. Any questions so far? Okay, now the things that happen now should always happen when we're doing this kind of problem. What should happen next is that 114 will disappear. It was not an accident that this turned into 114 and that this is also 114. That should always happen. The constant, whatever the function contains that doesn't have x's in it or variables in it, anything that doesn't have h's in it should go away. And it does. So what I have left at this point is 13h minus h squared divided by h. And I want rid of that h because I can't do this with that h in the denominator. So what I'm going to do is I'm going to factor out that h. Because h times 13 is 13h, and h times h is h squared, so I factored out the h. And now because I factored it out, I can get rid of it. And now that I've gotten rid of it in the denominator, I can let h be as close to 0 as I want it to be. It can be 0 for all I care. So 13 minus tiny h that's disappearing is actually going to wind up being what? 13. Is everybody good with that? What does that mean? Got to go back to the original problem now. Find the instantaneous rate of change in cost with respect to the number of cases produced when just one case is produced. If just one case is produced, the instantaneous rate of change is $13 per case. Okay? That's basically how fast is your cost increasing per case at one case. It's increasing by $13 a case at one case. Now that might not be the same at 2 cases, or at 3 cases, or at 4 cases. That would change because we would have to go back and we would have to do this instantaneous rate of change formula. Instead of using A as 1, we could use A as 2, or 3, or 4, or 5, and find out how fast the cost is changing at any of those particular numbers of cases that they've produced. Because unlike time or distance, which are continuous, the number of cases is discrete. So you don't make one case and then make a little more of one case, a little more of one case, and it suddenly becomes 2 cases. You make one case, and then you make some more to get 2 cases. But there's not really anything between 1 and 2 cases. You're not collecting information in between those. Okay? Questions? Now, just so that you understand how this works, because I'm not sure everybody was clear on this at the beginning, the homework actually in Shovie follows along with the homework that we do in the class notes. So example 2, the first problem is like example 2. In fact, you're going back to the same graph, but it asks you for 2 different points. Okay? And then for your turn 3, says for the function in example 3, which was the velocity function we looked at where the car was taking off at the traffic light, says for that same function, find the distance in feet of an object from the starting point is given by this equation. And you're going to use 2 seconds. Okay? This time I remember to copy the example down there for you. I think on one of the first ones where I meant to copy the example down, I didn't, and you're sitting there saying, what is f of x and g of x? How do I do this? And I realized that when I got the first question, but I couldn't go back and fix the handout. So I had to just tell you what it was, and I wound up going into most people's paper and just writing on there, limit as x approaches 2 of f of x is 3, and the limit of g of x as x approaches 2 is 4. And go look at this example. This is how you do this. So that's the idea of the homework, is that it kind of follows along with the examples that we do. And then example, or the third problem says your turn 4, because I don't give you all the your turn problems, I only give you some of them. It says if the cost function is given by this equation, find the instantaneous rate of change of cost when x is equal to 4. So that's the problem we just worked, except it's a different cost function and a different value of a. Okay? And the reason I want you to try to work these as soon as you can is so that I can make sure that you got what we were doing tonight. So let's go back to the PowerPoint and finish up this section, which we're actually very close to finishing it up. And I'm going to skip over the slides for that because I've done all of the work for those for you on the overhead. I think that worked better. So for example 5, before we talk about it, it's a little bit different. It's still a manufacturing problem, but it's not exactly the same. It says we define marginal cost as the instantaneous rate of change in the cost function. The word marginal is always represented or always associated with a rate of change or a slope. Similarly, the marginal revenue function is defined as the instantaneous rate of change of the revenue function. And the marginal profit function is defined as the instantaneous rate of change of the profit function. And what I want you to associate with the instantaneous rate of change in anything is that that is the derivative at that point. What we are actually doing right now is we're taking derivatives. And I'm going to be upfront with you about it. We're taking derivatives right now the hard way. This is actually the hard way. There is an easier way to do it. But in order for you to understand what they are, it's better to begin with a process that you can understand. So this is really the harder way to do these problems. Only because it's tedious arithmetic. So we have example 5. This is the same cost function we had a few minutes ago. It says that we need to find and interpret the instantaneous rate of change in cost when 5 cases are made. Now again, I'm not going to work from here. You've got it there to go back and fill anything you need in, but I would rather work it with you step by step. And with this, I think I want a clean sheet of paper. So we're going to be using the value of 5 for A. Other than that, we're doing the same thing we did a few minutes ago. So the cost function is the same as the one that we had before. And we're going to take the limit as h approaches 0 of f of a plus h minus f of a. And basically the reason the h is down here is because we're going from a plus h to h. I'm sorry, to a, not h, to a. So that's why we actually have a plus h minus a is just h in the denominator. So this is nothing but a slope formula. And for the example, it says a is equal to 5, because we want at 5. So we're going to let a be 5. So that means everywhere we had an a, we're just going to replace it with 5. And we don't worry about it in the denominator because all that's left in the denominator is the h. So the harder part of the math is to find what is f of a plus 5. In other words, this part. I'm sorry, 5. Apparently my brain and my mouth can't communicate tonight. 5 plus h, which means everywhere there's an x in this original problem, I'm going to plug in 5 plus h. So 100 plus 15 times 5 plus h minus 5 plus h squared. And then I'm going to try to simplify that as best I can. So 100 plus 15 times 5 is 75. And 15 times h is 15h. And 5 plus h squared is 25 plus 10h plus h squared. But I'm going to subtract all three of those terms. Okay? And then I'm going to go through and try to clean up the constants. 100 plus 75 is 175, and 175 minus 25 is 150. Nothing else changes. Plus 15h minus 10h. We still have an h term. 15 minus 10 is 5h. Takes care of those two. And then minus h squared. So this is f of 5 plus h. Then we're going to go just like we did before and find f of 5. No h, just 5. So that's 100 plus 15 times 5 minus 5 squared, which is 100 plus 75 minus 25, which should be no great surprise. 100 plus 75 minus 25 is going to be 150, which is going to make that 150 disappear. All we're going to have left is 5h minus h squared, and all we're going to have in the denominator is h. And when you factor out 5h minus h squared, you get h times 5 minus h over h. The h's cancel, and we're going to take the limit as h approaches 0 of 5 minus h, which is 5. Okay? And as before, the instantaneous rate of change in cost at $5 per cases, at 5 cases is $5 per case. Now compare that when it was at 1 case. What's happening to the instantaneous rate of change of cost? It's decreasing. Does that make sense? Now the best way to say this in English, and this might make it actually make more sense for people that are still trying to get it totally thoroughly integrated. Another way to write this that makes more sense to me, at manufacture of 1 case, cost is increasing by 13 per additional case. While at 5 cases, cost is increasing because it's still positive by only $5 per additional case. Okay? Now, is that marginal cost going to continue to decrease forever? Probably not, which is why they limited the cost function to only being good for up to 7 cases. Because you are eventually, does that help, Tarina? Eventually, in most logical settings, you know that you can't make enough cases to where the marginal cost or the cost of making 1 more case is going to be nothing. That doesn't make any sense. Even though it might shrink down a lot, At some point, you're gonna be at carrying capacity. At some point, you're not gonna be able to make any more for any less per case, because you've got that set fixed cost, right? You still got that fixed cost, and while it figures in less and less and less, it still puts a ceiling on how much your cost can continue to increase, and how much your profit can continue to increase, and how much your revenue can continue to increase. So you usually have a limiting factor on the number of cases that a function will work for, or the number of items a function will work for, because after that, it's not going to behave according to that function. There's going to be a limit beyond which it can't go. And what I'm trying to do with this is I'm trying to make sure it makes sense for you while you're even needing to do this. And folks, we are finished with 11.3. And it is 7:23, so I think we have earned a break.